Good morning and welcome to Wednesday of week 5 of your Physics 5 a day. For the last couple of days we've been writing lots of these decay equations. So we've been describing what happens in a decay. Now we're going to think about why it happens and when. Now when we say radioactive decay, we're talking about nuclei. It means when an unstable nucleus turns into a more stable nucleus by emitting one of our familiar types of radiation. Now, if you ask what an unstable nucleus is, it's one that's going to decay. So a bit circular there, but we're not going to worry about it. Quick note on terminology. Nuclei are unstable. A material is radioactive. So a radioactive material is one whose nuclei are unstable. That's the correct way to use those words. And another quick note, nuclear fission and fusion, they're a different category of nuclear reaction. So when we say radioactive decay, we do just mean one nucleus turning into another by emitting one of these types of radiation. Okay, but why is this so interesting? Because it's very strange. If I have a sample of a radioactive material, I do not know which nucleus is going to decay next, and I don't know when it's going to decay. And that's what we mean when we say that radioactive decay is random. It's also spontaneous, and that means that even after a nucleus has decayed, and I know it was that one, that's the one that decayed, I can't tell why it was that one. So you might think, well, it seems like we can't know anything about radioactive decay, but that of course is not true. What we do know, for any particular radioactive material, we can work out how many nuclei are going to decay per second, and that's called the activity, the number of nuclei decaying every second. It's measured in becquerels, where 1 becquerel is 1 decay per second. And what we know about the activity is that it's directly proportional to the number of nuclei that you've got left. And if we have a directly proportional sign there, we can of course replace it with a constant. And so this is our decay constant there. Now this is actually a very special and significant mathematical relationship. Whenever you have the number that's disappearing per second directly proportional to the number you've got, that means that you have exponential decay. So that's when we get these two formulae. For those of you that do A-level maths, this relationship is that, and if you solve that, you get this one. But you don't need that for your A-level. All you need to know is that because of this, n decays exponentially. And then because n is directly proportional to a, that means that a is also going to decrease exponentially. And so we get our characteristic exponential decay curves. Now these are of course very precise mathematical relationships, and we'll see that in the next video.